This video will teach you basic trigonometric regression. We're going to use the regression tools on our calculator to find a sinusoidal equation for this data. So just a reminder, in order to get there, we would, oh, that's kind of small. So we would go to the stat button and then edit, stat edit, and then all of your X values would go in L1 and all of your Y values would go in L2. I've already taken the liberty of typing all these in. Then second quit to go back to the main screen, stat, hit the right arrow to go to calculate, and then you have to find the sinusoidal regression. That's letter C on your TI-84s. So if we are, if we're looking at this, 3 iterations seems good to me. We also seem to know what the period is on this because it appears that the period is 14. So it's showing us that apparently the first time that we get back to about the same spot is 14 later. So our period is 14. And I will store my regression equation in Y1. Then I will click calculate. Then this ends up being my sinusoidal regression equation. So notice that A is in front, B is here, C is here, and D is here. Also notice when you have something like negative 1.982713 e to the negative 4, that's 0.0, it's negative 0.000198. It's that could be something that we kind of keep around, but generally speaking, this probably means pretty close to 0 since we're doing a regression equation. And all the points won't exactly line up with everything. So this is basically 0, which makes a lot of sense because there would be no horizontal shift since from 0 to 14, they would both be at 4.3. We would pretty much assume that that is not going to be the case. So when I write my answer, it will be y equals 2.698 sine of 0.449x. Then remember, when I have this c, it's 0.000198. It's very, very small. That's technically practically 0. We're going to kind of leave it like this since there is no horizontal shift here, and then plus 4.300, which again makes sense because that's what appears to be the vertical shift of my sine graph. So that would be what it would look like. And if I wanted to show it on the graph, I would have to turn on my stat plot and then go to zoom stat. And then I can see it. And it lines up pretty well with most of the points. So now I'm going to do one more quick problem. I will type these into the calculator. So we will go to stat, edit. If you go up and hit clear on L1 and L2, everything goes away. If you go up to L1 or L2 and hit delete, that's a really bad idea. So don't do that. So 2, 7, 12, 17, and 22 were the X values. Then the Y values were 30, 65, 100, 65, 30. So then I'll go back to the main screen, stat, then do a sine regression. The period appears to be 20. And I will store my regression equation in Y1. then when I calculate, I end up with this as my answer. So I can write this. So y equals 35 sine of 0.31415. That looks a whole lot like 1/10 pi. So pi over 10 x minus 2.199 plus 65. Now, I want to think about this for a second because it appears that I have from 2 to 22 showing up as the same, and then 7 and 17 are showing up as the same values of y, and this is going up by 35, and then this is going down by 35. So if this is sinusoidal, then what's probably happening if I just did a little quick graph, if this is if this is 30, and up here is 100, 65 is right in the middle. This looks a whole lot like a negative cosine graph. Negative cosine, now I would need negative 35 cosine, and then I have, well, what's the period? The period appears to be 20. So if the period is 20, that's equal to 2 pi over b. So b must equal pi over 10. And then I have no horizontal shift for this. And then I have plus 65, that'd be my vertical shift. So if I look at this, it would be just pi over 10 times x for my cosine thing. Now if I think about this, are these two things the same thing? Well, if I look at the sine graph, so for example, this is 2, this is 7, what would happen if I do, if I factor this out? So if I factor out this pi over 10, well, if I factor out the pi over 10, what I would end up getting is negative 7 when I factor out this pi over 10. This is just a rounding error because I didn't type in enough things and stuff like that. So what I end up with is a minus 7 here, and that makes a whole lot of sense because this graph with the sine should match up identical with the cosine graph that I got just by understanding what these 5 points will give me on the graph. Now, what makes this different from one that doesn't have exact points is that a regression equation gives me a line or a curve of best fit. And so this one is giving me something that fits the graph the best out of all possible sine or cosine sinusoidal graphs. Whereas this one fit it perfectly because my data ended up matching up perfectly with the exact amount of shifts and the exact amount of stretching and things like that that would make this work out exactly well. But regression equations don't have to do that. Regression equations do have the ability to give us a best guess when things don't work out exactly perfect, like many times they don't.